much in math.
Yeah, I'm a scientist. at heart,
Yeah.
so. Yes, sir. You have a copy of this?
I just didn't print.
I have enough.
I don't have a copy.
I can bring one real quick.
Yeah, maybe you can print one. I gave my last copy.
I can put no problem. We'll have it done.
You want me to get it?
Yeah, but it's because I need to find it.
Emma.
I got it.
Got it?
Yeah.
Ooh, look at that. That's a nice pencil there. It's kind of tricky finding. I keep forgetting to take that over and like use a good pencil sharpener.
I was finding it. Miss Sibyl called me. I answered my phone. I hit accept with this hand, and then I just wanted to transfer. It was like a cartoon. I'm sitting there like, oh, hold on, hold on.
All right, you good? You'll print out a page for him? Yeah, okay. So today we are going to talk about the dropped object model. And unfortunately, I should have this as like a little vocab term in the notes. Sorry, Jason, I'm gonna write. I'll just make a little space here for it. Next year, I'll have it its own little spot. But I think you have enough space at the top there that you can add this in. Michael will go slow so that he's quick. So when you drop an object, hopefully not a phone, it falls. Obvious, it's not going to stop. But when you're dropping that object, there is something pulling on it, and that would be the gravitational force of the Earth. So because of that, it falls at a slower rate. And if it were on a different planet, it would be a different rate. Each planet has a different gravitational pull. So depending on the planet you're on would depend on the quickness or how fast it would drop from wherever it's being held. That model is a little formula. And that formula will be given to you is h equals negative 16t squared plus h with the little 0 underneath it as a subscript. There are two h's in this problem. The first h is the ending height. And way back in chapter 1, which was so long ago, we wrote equations as well to represent height, except we did like the height of the floors in a building or in a hotel. But we did an airplane as well that was kind of falling. So we did look at some equations and writing equations. So the ending height is just the regular h. And then the negative 16 is there because of gravity. The gravitational pull in feet per second squared is 32. So that would be negative 32 feet per second squared. That's kind of like at the quickness or how an object is being pulled toward the center of Earth. That's why the negative 16 is there. T is time. And in math, we always use T for time. And then h with the little 0 is our initial height or the starting height. So we have the ending height and the starting height. Think of the 0 as being like, where does it originate from? Its original height. So the original height is 20 feet above the ground. That's the h sub 0. So this is the equation for objects that are dropped. And again, only objects that are dropped are objects that fall from something, not a thrown object that would kind of propel at a different height, a different angle. So this specifically only works with objects that are dropped, which would be a skydiver. I think we talked a little bit about this on Friday. A skydiver jumps from an airplane that is 6,000 feet above the ground. The skydiver opens her parachute when she is 2,500 feet above the ground. So I've never gone skydiving. Mr. King, you said you want to, but you have not done so, right?
No, Grove City, I know people that actually work there.
Oh,
Yes,
okay.
as skydive instructors.
But when you jump out of a plane, you like free fall until a certain point. And then there's somebody on your back that's with you, attached to you, and you click a button. And then when you click that button at the certain time, which I'm sure the person on your back tells you when, then the parachute opens and then you fall at a slower rate. But that initial amount is like a quick, like free fall amount where you're just dropping in the sky. So my friend, her senior year of college, went to New Zealand. And while she was in New Zealand, for some reason, she did skydiving. She did bungee jumping. She did all these crazy things while taking her last semester in New Zealand of college, which was a pretty cool thing to do. But anyway, so we want to write an equation that gives the height of the skydiver above the ground. It says as a function of time in seconds. So we're going to use the equation h equals negative 16t squared plus h and then that little 0. So the first goal is for us just to plug in numbers for this equation. Write an equation that gives the height of the skydiver above the ground. So when the skydiver is in the plane and they jump out of the plane, how high above the ground are they, Peyton, when they jump out of the plane? 6,000 feet. That's the starting height, which is a little more than a mile above the ground. So a mile is 5,280 feet, and they're 6,000 feet above the ground. So that 6,000 feet is our original height where we're starting at in the sky. So we're going to plug that in for h sub 0. So our equation, the only thing we replaced was that h sub 0, h of 0. So I have negative 16t squared plus 6,000 because that's our initial height. This is an equation that gives the height of the skydiver above the ground as a function of time. And I know that sounds weird and confusing, but that just means I'm solving for height and I have time in my equation. The second part, how many seconds does the skydiver fall before opening her parachute? So our little skydiver is at 6,000 feet. They fall until 2,500 feet, and then they open the parachute. We want to know how much time does it take to go from 6,000 feet to 2,500 feet. So that's the goal.
This would be a good calculation to have if you're looking at your watch and then you're looking, oh, I need to pull in 10 seconds.
Yes, to
If you
kind of
messed
know.
up- Yeah, if you messed up on that 10 seconds, you might be hitting the ground before you shoot it.
So yeah, again, that's a very good point. So kind of to know when you need to pull that parachute. So again, 6,000 was our initial height. We're dropping to 2,500. That 2,500 is our end height. Because at that point, then she's clicking her button, or he's clicking the button for the parachute to open. So initial height is h with the little 0. Right now, we're still in the sky, but we want to know how long did it take to get to that 2,500 feet so we can open our parachute. Questions about those two numbers and the placement of those two numbers? So that last H is how, like, where are you ending? How high above the ground would you be located? We're 2,500 feet above the ground. So now we have an equation that we've been working on, and we want to try and solve this for T. So think about the process that we used last week. Michael, what would be the first step that you think you do to solve for T? Yeah, so let's take that 6,000 to the other side. That's a number. We need to isolate the T squared, so we'll take that number to the other side. Michael, do you know what 2,500 minus 6,000 is? And that shows you how many feet she's fallen or he has fallen in the air. So they have fallen 3,500 feet. So that's what that number represents, the distance they actually fell. What would you do next? Emma, what do you think you would do next? We have that trying to get T by itself. Yeah, let's divide by -16. Now, because this is an actual real life problem, we are going to get decimals. So in your calculator, I do want you to actually divide this number. So we're not going to leave it like this. We are going to get a decimal. Somebody with a calculator actually divide this out. Emma, do you have a calculator on your iPad? Yeah. What did you get? 218.75? And then that's still equal to T squared. So what's the last thing that we would need to do then? Michael, what do you think? The last thing we have to do? Square root both sides. Because remember, we're trying to solve for T. So we're going to square root both sides of the equation. Also, plug that in your calculator. And Michael, what did your calculator tell you? Yeah. Or you could say 14.8. And that's time. And what is our time being measured in? What does the question say? What's this represent? Jason, do you know what that number represents? How much time? 14.79 seconds, yeah. So how many seconds does the skydiver fall before opening her parachute? So she starts in the plane, she jumps out. She falls for 15 seconds almost in the air, just free falling, dropping. She's falling 3,500 feet in 15 seconds. That's crazy. Like this is probably, I don't know, 9 feet, 10 feet, maybe?
Probably 10.
Probably 10. So this is 10 feet. She's falling 3,500 feet in 15 seconds. And then she clicks the button, the parachute opens, and then she'll fall at a slower rate.
Wow.
Questions? Like that's a lot of distance in a very short amount of time.
Go Scott.
Anybody interested in trying that? Yeah?
Two.
Dropping 3,500 feet, 15 seconds. Like, holy cow, what a rush. Yeah. Questions? All right, so there are 3 final wrap it up problems at the bottom that we're going to work through. Let's just do 2 and 3. So we'll do those final 2 problems, numbers 2 and 3, to give us a little refresher of these problems. And then we'll look at, see if Mr. King can do one more word problem on the homework with you and maybe another problem or 2 as well. So number 2 looks similar to the word problem, except we have an X instead of a T. So Peyton, the first thing you would do for number 2 is add 10 to both sides. Yeah. So get those 10s to cancel. So remember, we talked about 2 different forms for these equations. On Apple TV. What a delay today. The next step after you, there it goes. Add 10 to both sides. TJ, what would you do next? So we have 7x squared. So what would you do next? Before that, what's in front of the x squared? There you go. Do you know what 35 divided by 7 is? 5, yeah. And then TJ, you would square root. So when we're looking at those numbers, we have 4, 9, 16, 25, 36. 5 is right above 4. Is there a perfect square that goes into 5? No, it's just the square root of 5. Only 1 times 5 makes 5. So your answer is going to be x equals the square root of 5. But what goes in front of that square root of 5? Do you remember? What was in every single one of these problems? Jason, do you remember what we put in all the problems? Excellent, a plus or minus. Don't forget that little part there. Every answer has a plus or minus somewhere in the problem. All right, last one. Michael, what would you do to solve number 3? Yeah, so in this problem, we have parentheses, and we're going to get those parentheses by themselves by dividing by 2. So that cancels, but you still have x plus 5 squared. Michael, what is 32 divided by 2? 16. All right. Now the parentheses are by themselves, just like the x squared was by itself. Emma, what do you do to get rid of that parentheses squared part? Before that, we have to take the square root. Our goal is to get that little 2 to cancel out. And to get the 2 to cancel, we have to take the square root of both sides. So we end up with x plus 5. Emma, do you know what the square root of 16 is? 4. And again, a plus or a minus. Anytime you take a square root, as soon as you take that square root, don't forget that plus or minus. And then, Emma, how would you get x by itself? Now we subtract 5. So remember, these were the problems we did on Friday. We have a -5, a plus or minus 4. So these answers are a little different than the problem right next to it. So a little different when we have parentheses. So this is those 2 problems, -5 plus 4 and -5 minus 4. So slightly different. Peyton, what are our 2 answers? -5 plus 4 is? -1. And then -5 minus 4 is? -9. So please make sure you look, if you were working ahead, that's awesome. But look to see what you did for this last problem because it is totally different. So you have these 2 separate answers. That's what we talked about on Friday. Any questions? So we have a little more than 15 minutes, maybe like 17 minutes. There is a worksheet that'll be posting to Google Classroom momentarily that we are going to work on. There are 2 word problems on the worksheet. And then it's just a final kind of summary of these equations, solving the equations before we completely do a review tomorrow with reducing radicals and solving equations in the radical form. So if you want to open up this worksheet, you can send it to Google Classroom. Oops.
Start with the word problems.
Yeah, I think that's an excellent place to start.
Anybody musical? No. I kicked off over the weekend.
Yeah, it did. Okay, I think we're good.
And Thon this weekend, anybody going there? We got some for Thon. Good. Okay, so if we look, we are going to scroll all the way down to numbers 15 and 16. And these are both very, 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 very identical to the one that Miss Kane did with me. Number 15 says the Golden Gate Bridge in San Francisco, California, just a little bit away from Alcatraz, was under construction from 1933 to 1937. Suppose a construction worker dropped the tool from a point on the bridge that is 220 feet above the water. Part A asks us to write an equation that gives the height in feet of the tool above the water as a function of time in seconds. We're going to use the same formula where we have an h, a t, and an h sub 0. Who can tell me what h stood for again? Does anybody remember what h stood for and h0 stood for? Good. So h is that's going to be your finishing height, correct? So your starting height is going to be for your h sub 0 is going to be your starting height. And this problem, that's pretty easy because they gave it to us. What is it in this problem here? Jason, what's the starting height? Yeah. The starting height in this problem is going to be 220. So now we want to look for h. If h sub 0 is our starting point, then Michael, what would h be? It's not where it starts, it's where it ends. Yeah, so ending point or finishing point. So think about it, if I drop this, boom, it hits the ground. How high is it off the ground? 8 feet. If it's laying on the ground. Think about if you're measuring somebody. This tall, they're 4 feet, this tall, they're 2 feet. If they're this tall, how tall are they? Anybody? 0. 0 feet. Yeah, if it hits the ground, you're 0 feet high.
Everything is measured like height-wise from the distance from the ground. So if you're on the ground, you aren't tall at all.
Yeah. So it's 0 feet. So now we're just going to plug in. 0, or h, is going to equal negative 16t squared plus the 220. Does that make sense how we got those numbers? From here, we're going to use that and we're going to solve. So 0 equals negative 16t squared plus 220. Peyton, what's our first step to solve for t? Yes, subtract 220. When you do so, you get negative 220 is going to equal negative 16t squared. TJ, what's our next step to solve for t squared? Divide, good. So we're going to divide by negative 16. And what is negative 220 divided by negative 16? Say that one more time. Okay, so 13.75, right? So we get 13.75 is going to equal t squared. Michael, how do we get rid of the t squared? By taking yeah, you take the square root of both sides. And you're definitely going to need to do this in the calculator. When we get t, what do we get when you take the square root of 13.75? Does anybody need help putting it in the calculator? So we can show you how to do that. Jason, what did you get? 3.7, good. And 3.7 what? Yeah. That's it.
Everybody okay putting that in the calculator, finding that square root that's?
Yeah, I mean, that's definitely something we're gonna have to do. 16, we go faster because it's the exact same problem. It's just worded different. Niagara Falls is made up of 3 waterfalls. One of the falls is the Horseshoe Fall in Canada. The height of the Horseshoe Falls is 167 feet. A log falls from the top of Horseshoe Falls. How many seconds would a log take to reach the bottom of the falls? We're using the same thing. So remember, H is our ending height. Peyton, how many feet is it when it falls to the very bottom? Okay, and then when it hits the bottom, it's considered how many feet? And when it hits the ground, how many feet high is the ground? If you look above the ending height. So if you look at our number 15 up here, what was our ending height for the problem? It's up on the board. The ending height was, so we're going to go 0 is going to equal -16 t squared. And then now is where you put the initial height of 167. So all we're doing is we're plugged in and now we're going to solve. First step to solve, subtract 167. And then Bill, what's going to be your next step?
Divide by 16.
Good. And then make sure that's a -16 when you divide. And then what do you get when you divide by -16?
Negative 10.3475.
Good. Everything's good except when it's a negative, it's going to give you a positive. So you said it's 10.475. I'm sorry, 375.
4375.
4375.
4-3. I'm losing my mind. 437. That's going to equal t squared. The next step is taking the square root of both sides. And then Jason, what did you get when you took the square root of this? 3.22. And then what is that in? Seconds. So that's it for the word problem. Any questions on those word problems? Okay, the rest is just review. If you have any questions, you want me to go over a couple?
If you want to do like one of these quick, and we print this one out, but
Yeah,
doesn't matter,
we just
what I
did
do
them.
as well.
Would you guys like me to do?
Yeah, are there
any
any
of the-
questions that you want to go over on the worksheet?
I'd love to go over a couple. Michael, anything you'd like me to do?
First 6 have, number 5 has a fraction, but the first 6 don't have parentheses, and then the next 2 do.
Yeah, let's do number 5.
That's 2 over the fraction.
Yeah. Anya, how do you solve for X? What's the first step? Okay, we're gonna add 8. So 1/2 x squared equals 24. And Michael, how do you get rid of 1/2? Yeah, you either multiply each side by 2, or you could divide each side by 1/2. You'll get the same answer doing either way. So if we multiply by 2, you get x squared equals 24 times 2, which would be 48. Now we're going to take the square root. When you take the square root, we want to find what perfect squares go into 48. Anybody?
Let's look at that square root list.
4,
This number
9,
that goes in there.
16, 25, 36. 16 and 3, good. What's the square root of 16? Plus or minus 4 square root of 3. That's it. So leave that one for you. If there are any more, please just shout them out. We have 6 minutes. We could go over a bunch. And you're not sure about, we could do that together.
So again, the first group of problems are like this problem, and then the second group of problems have the parentheses in them, so like the last problem we did.
Yeah, and I'll do number 7 below and I'll keep them both up on the screen. The square root of 49.7. Remember, you have to put the plus or minus 7 with that. You add the 6 over. Get k equals 6 plus or minus 7. And this is where you separate into 2 separate equations. 6 plus 7, and then k equals 6 minus 7. 6 plus 7 equals 13. 6 minus 7 equals -1. And there you go. You got your 2 answers. So I'll leave these all up there.
So 8, 9, 10, very similar to number 7. 9 and 10, you just have to divide by that number first.